Good afternoon. So today we are going to seeing about the topics threadmill. So there is a today's session. Threadmill for beginner, it's a complicated one. Already we have got some much experience in manual programming, having some threading knowledge, so that people can easily understand the concept. But for sure, threadmilling is little bit difficult for learning and as well as for understanding purpose. Why means the threadmilling? What is meaning by threadmilling? So it is used to create the thread by using IJ program, not a G84, not a M29. So the thread milling, it is also the process of milling operation, the tool which can be used for thread mill. So the name of the tool is called single edge tool, thread milling forming tool. Likewise, so it is used to form the thread with IJ program. So thread milling is the metalworking operation used to create the internal and external threads of different sizes through the circular movement of rotating tool. There is a difference between tap and thread mill. So the thread mill, it is used to make the thread on the side of the wall, OD or ID, anything. But circular movement, it is used to make the thread. That means the circular movement of the table, at the same time the spindle is rotating the tool. So both are used to create and used to form the thread on the side of the wall. This is a thread milling. It is also called as another purpose of using unstandard thread or creating the thread, not a standard thread. Standard thread, we people are using the standard tools like M10 tab, M8 tab, M6 tab, M3 tab, M12 tab, M15 tab, like this. But thread milling, this is totally having some unique feature compared to tap. Let's see that what is the thread milling in Mastercam. So I just go to the drawing. Now I'm going to make M27 thread which have got 3 mm pitch, big thread, M27, or otherwise M54 thread which have got pitch value is 3 mm. But why means the tapping size, the standard tapping size so up to the standard tap size is up to M68 into 6 mm pitch. It is a standard tapping size. Okay, up to M68. But now I am going to take M80 into 3 mm pitch, because that M80 is not available in the standard list. See here. So minimum M1 that means M 1 mm thread, metric thread, 1 mm dia, 0.2 pitch, that is a minimum, and maximum up to M68, 6 mm pitch. Now I am going to construct M80 into 3 mm pitch. So I just taking the rectangle size 100 into 100 and wireframe here 80 dia. So 80 is my M80 into 3 mm pitch. So that M80 means metric 80 mm diameter. So that diameter I drawn. So the next process into 3 mm pitch. That's why I just taking here M77. That means 77 dia. So 80 minus 77, 3 mm. So that 3 mm I consider the calculation for making the thread mill. So outer diameter designer is gave, that means customer is gave, but inner diameter we have to find out. How to find out? There is no big formula is there. Just the formula is major diameter minus pitch equal to minor diameter. So my major diameter is 80 minus my pitch 3 mm. So the minor diameter is 77. Now right click, isometric, solid, extrude. $50 okay, and I'm going to cut body, that's 77. Okay. Now this 3 mm difference, I would like to remove the material on the wall. At the same time, I would like to form the thread on M80. That is a M80 into 3 mm pitch. Now view toolpath, machine, milling default. Property, tool setting, program number, stock setup. I'm going to take this entire solid body into casting piece. Select the solid mesh, select the body and click OK. Now I just hold this page by clicking this pin, and now I'm going to select thread mill, helical motion. It is used to create the helical motion threads on the material. Yes. Now I'm going to select, but my first session is inner thread. How to form inner thread? M80 inner thread in an entire rectangular body. So I want to make inner thread means I don't want to select the outer diameter. I should select inner diameter for inner thread. 77 and click OK. Now go to tool. Variety of tools available for particularly this operation. Thread milling tool. Variety of tool is available. So this is a multiple edge which have the multiple teeth, and single edge also available. Single edge. This is a single edge tool. Single edge. This is a single edge which consists inbuilt what? Chamfer. Inbuilt chamfer. This is a multiple edge, have got 1, 2, 3 edges. Okay, single edge, multiple edge doesn't matter, brother. So what is the main thing? Single edge means it will lead to some cycle time greater. Multiple edge means it is reduce the cycle time. That's it. Okay, depend upon the cost wise. You have a much money, you will purchase the multiple edge tool. You have a less amount of money, you purchase the single edge tool. Okay. Now I'm going to select the single edge, right click, create to, thread mill, next. So this is a multiple edge. This tool is multiple edge tool, and here the lots of threads are available. Metric, unified pipe thread, unified national thread, Acme thread. Acme is look like a square thread, similar to Acme thread, and here Acme truncated stub thread. It's look like a stub. See the teeth. Okay, next one, buttress thread. It's look like a butterfly. See, buttress thread. This is a buttress thread edge, teeth, thread teeth. And then next one, buttress pull and buttress push. Buttress pull means the taper angle at the which is seen at top of the, it's look like sitting at top, but push means it's down. See, it's down. So buttress pull means look like top and buttress push means downside, looking downside. Wait. It's looking downside. And here American National Pipe Thread, NPT thread. This is NPT thread, tapper thread. This is a tapper thread. And now I'm going to selecting metric thread. I'm going to select single edge tool. So pitch, I'm going to give my desired pitch 3 mm and cutting length also 3 mm and the outside diameter 12 mm. Okay, 12 mm or otherwise 16 mm and shoulder length, okay, 40, shoulder diameter 5 and shoulder shank diameter 6. This is the single edge tool which already seen that picture like this. Single edge tool. Okay, so I took 15 mm cutter and click OK. Now I give the feed rate 70 and spindle speed 1000 and the plunge rate 100 and go to holder and go to cut parameter. This is the thread mill cut parameter and pitch is already taken by Mastercam because I mentioned the pitch previously in tool selection. In that page I just mentioned the pitch value in pitch column. Okay, so they're asking thread starting angle, later we discuss, and allowance overcut. Allowance overcut means major dia minus minor dia. So the difference value 80 minus 77, so 3 mm is my difference. 3 mm stock is there. I want to milling simultaneously making thread. That's why the name is called thread milling. Okay, so now via mode ID thread, just click this overlay geometry and just give the right value. What is the outer diameter? 80 mm. Now I'm selected right hand thread bottom to top because already one hole is created there. There is no material which is present at the middle of the workpiece. So already one big hollow is there. So why here ID thread they are giving in Mastercam suggests bottom to top is the climb milling and top to bottom is the conventional milling. But OD thread top to bottom is the climb milling and bottom to top is the conventional milling. So later we will see outside diameter thread forming. In that time I will detailedly explain. Now ID thread, in that ID thread I am taking bottom to top, that is a climb milling. The tool is directly goes down to bottom and start machining from bottom to top. That is the ID thread bottom to top climb milling. Okay, now major diameter done, right hand thread done, bottom to top done. Allowance overcut 3 mm for milling, major diameter minus minor diameter. Okay, now lead in, lead out. Keep it the same value, don't make any changes here. Start at center, end at center. And helical entry, this is some 99% very important one. Don't disable the to function which contains the name called helical. Okay, don't disable, because the thread milling is working based on helical motion. If you disable helical motion means thread milling is totally waste. Okay, so now start at center, end at center, switch on these two. And now go to the multi-pass. Why? Because 3 mm stock which is present at the major and in between minor. So now I'm going to here multi-pass. I'm going to give here and 3 mm stock is there. Okay, 1.5, sorry, number of passes, 2 passes, and the step over is 1.5. I give 2 process because 3 mm stock is there. I want to remove some material under the limitation such as 1.5 mm multiple 2 passes. Okay, now I just directly go to linking parameter, absolute, clearance 50, retract 3 mm, feed plane 3 mm, and depth I'm going to give through hole. So this is the thread milling tool path motion. So the green color shows tool entering area and the red color shows tool exiting area after completed the operation successfully. Now I want to change the position of tool entering and tool exit. Go to parameter, cut parameter, starting angle. Now I'm going to give 90 degree. Let's see what will happen. Yes. Okay. If example I'm going to give here 180 degree. Yes. So this is 90 degree, this is 0 degree. Likewise it's changing that. Wait. 270. Yes, this is 90, 270, 180 and 0 degree. Okay, once again I explain. 90 degree, 90, 270, 180 and another one. Now how it is running? But before that, the tool entry and tool exit, what is the angle, in between angle, what? Just go to parameter, lead in, lead out, 90 degree. 90 degree is the angle between lead in and lead out. If example I reduce the angle, yes, I'm reducing the angle means it increasing the lead in, lead out position. I'm decreasing the angle means so it shows like very near lead in and very near lead out. Okay, so now I'm going to giving here 50 degree, 50. Okay, fine, good. This is right, good. Now already I showed to you what is the top angle in cut parameter, starting angle. Okay, starting angle means the tool is starting. So now 270 degree I'm giving means this is 270, this is 90, this is 180, this is 0. Okay. Let's see the simulation. This is the bottom to top. This is a thread milling, which is used for creating the thread on the wall. Example, pipe or otherwise solid block, anything. It is used to create the thread on the wall. Side by side, it is used to remove this 3 mm stock also. Now I change the stock here, just translate. Now see and right click in front view. Now see the thread. This is a thread. Now the first multipass is running, later the second multipass will run. Fine. Again comes to down for second multipass. Okay, see here. Okay, now the thread is completed. See here, right click, front plane. Yes. Now the thread is completed. 3 mm stock also gone. Check it out. One time you check it out. Now see, there is no 3 mm stock. There is no 3 mm stock. This is a thread milling. Okay, I just make it for inner thread, ID thread. So here you just mention the starting angle of the thread. Here major diameter minus minor diameter and just give the value here. If you want to need taper program, yeah, you just create taper thread also. ID thread, OD diameter mention here, and right angle, right hand triangle. Okay, that means right hand thread, and here bottom to top. Okay. Bottom to top means the tool is directly goes to down position and start the milling and slowly reaching the up position. Okay, so this is a thread mill. So lead in, lead out, this angle is controlling lead in, lead out, and here, yes, all the tick marks are generated. Just go to linking parameter. Yes, everything is same. Okay. Okay. Now how to construct the multiple edge? Go to parameter, tool, double click, and here I am going to give 15. 15 means how much? 1, 2, 3, 4, 5 edges, 5 edges. Now click finish. Now click OK. Lead in, lead out same, no problem. Now see. Super. Just 3 pass. Now the second multipass is running. 1.5 mm. That's it. This is a multiple cutting edge tool which is used for forming taper hole. Taper thread. Okay, taper thread. That means thread milling. I just explained. Okay. Now I'm going to take open thread. How to make open thread? Now I am going to make the open thread, wireframe, circle, dia 35. Okay, now go to view, toolpath, machine, milling, default, property, tool setting, program number, switch on this one, stock setup, all solids. Okay, now go to thread mill, select the entity. Okay, now go to tool, right click, create tool, treadmill, next pitch 3 mm pitch or 2 mm pitch, outside diameter 50, edge cutting length, thin edge, two means if example I am taking single edge means I just mentioned the two here, that's it. Now click finish. Now reduce the feed rate 60. Now reduce the spindle speed also 1200 and the plunge rate 50. Why I give plunge rate 50? Now there is no material inside the pipe, correct? There is no material inside here, but I just precaution, it is just for precaution, or otherwise we give 450 also, no problem. And now go to holder, cut parameter, starting angle 0 degree, okay, allowance overcut, major, minor. I only have one circle, I don't know which is major, which is minor. Allowance overcut 0, taper angle 0, wear, ID thread, okay. Now everything is same, you just enable this one and mention the value here, outer diameter. How much our outer diameter here? So home, analyze entity, $35, good. Okay, that is my outer diameter. Okay, but you people want to make 3 mm pitch, right? Then why then why we are selecting like this? If example, okay, M35, not a M35, just go to circle and make the pitch here, example 38. Okay, now because 3 mm pitch or 2 mm pitch, okay, sorry, wait, I delete this one, circle 37. Okay, now go to geometry, right click, delete and select the 35. Okay, now go to parameter. I already took the tool which have diameter 15, pitch 2 and the cutting length also 2 mm pitch. This is a single edge type of tool. Get finish and here feed rate everything, okay, no problem. Holder, okay, cut parameter, ID thread, major thread diameter is not a 35, it is not a 35, it is a 38. Okay, now right hand the bottom to top, yes, super, all the things are same, you don't make any changes. Now go to lead in, lead out, five mm, 90, no, 180. Okay, Let's see what will happen. Right. What happened? Home, analyze entity, 40 mm. Okay. Now the toolpath is generated, but see, yes, what is the problem? Our origin is the problem. Okay, transform, move to origin. Right click front plane. No. Okay, I just move the corner. Transform, move to origin, corner. Now go to stock setup, unselect all, again select all solid. Okay. Now just refresh the thread mill concept, just refresh. Now the program is developed. Okay, so this tool is working based on bottom to top. That's why the green color entry is at the bottom of the workpiece and the red color is at the top of the workpiece. Now I took single edge tool 15 dia here and the cut parameter major diameter 38 and the minor, which is my desired tap size, that is my minor. Outer diameter why I am taking for pitch difference. So here the allowance overcut I am going to give 38 minus 35, 3 mm, 3 mm. Okay, so top to bottom is there, sorry, bottom to top, right hand thread, lead in, lead out, everything same. Okay, multi-pass, no, and last pull it. Wait. Now why the stock is there? Because I forgot to give multi-pass. See here, here also stock is there, here also stock is there. I just forgot to give the multi-pass. Now I'm going lead in, lead out, okay, no problem, lead in, lead out, okay. I give start at center, end at center, helical entry, okay, super. I did not make any correction, I did not adjust any correction in this columns, in this page, but multi-pass I forgot. So give multi-pass. Our wall stock is 3 mm, 3 mm stock we have. So I give here, first multi-pass is 1.5 mm, 2 passes I need. So finish pass, you people already have a good knowledge in contour, dynamic, anything. Finish pass in depth of multi-pass, I already clearly explained. So finish pass is mainly used for better wall finish. If example you take here the number of passes 2 and just give here 1 mm. So remaining the final pass, last 2 passes and you give 0.5. Otherwise you give one finish pass, 1 pass 0.5. Rough pass here you give wait, if example total 3 mm, 0.5 is finished there, remaining 2.5 mm. So 2.5 divided by 2, 1.25, 2 passes. Good. Now the feed rate I am adjusting for particularly finishing. I'm going to reduce. So how much of feed rate here? I'm taking 60 and 1200. So no, don't give 1200 because it's a threading process. So you just give 1000 or 800 also better, no problem. So I just going to control here. My feed rate is 40. If for example I increase the feed rate 120 and decrease the spindle speed 850. Okay. Now check it out. How to create the wall thread. Now open wall thread. Straightly on. Now see what will happen. What will happen? One time I show to you. What will happen? The tool is going to bottom to top. Why? Because already I take the class. Same class right now. I just 10 to 15 minutes back. Previous. I just take the class. In that time, what I told you, ID thread means you should use bottom to top. But brother, you just what I tell because you already make the open pocket there. Then you take the material means no problem, brother. You directly take the thread mill. But now we took the stock setup entire solid body. That's why the tool is running like that. See, the tool is damaged. Now the tool is totally broken. But previously we people not done the thread mill. I just going to take here circular milling for clearance, stock clearance. Okay. Now I'm going to here the tool path. And here circle milling. I just select not this one and select this one, that ID 35 and click OK. Now go to tool, select this tool and filter none flat end mill, and I'm going to select the diameter total 35. OK. I want to rush up the tool path. Rush up means rush up the production. As soon as possible, I would like to complete the process. So that's why I'm take the cutter 32. Because my diameter is 35, I'm taking the cutter is 32. So nearby 1.5 clearance is there. So 32, but don't take very big cutter for circle milling. Why means the circle milling is otherwise called a circular interpolation, that is using end mill cutter, using IJ program for making the hole, not a drilling command. So absent G83, G73, that is a hole making concept is totally absent. Using end mill cutter, not a drill bit, using end mill cutter and creating the program by IJ and making a hole. That is a circle milling or circle interpolation. So now I'm going to take the tool not a 32 because I want to give some space for tool rotating and table rotating. So that's why I'm going to take 25 mm cutter. And now I click OK. And the feed rate I'm going to give here 350 and the spindle speed 2000. How much cutting speed? 157. If you're using a carbide tool, the carbide tool will accept maximum 200 mm for cutting speed. Maximum 200 meter per minute. So now 157, so no problem. But plunge rate I'm going to totally reduce. Why? Directly plunging on the workpiece. Okay, good. Now I'm going to hold okay. So cut parameter, taking the program via over geometry 35 is my selected entity for making program. Starting angle 90 degree. I don't want to leave any material on selected component. 0 0. Roughing I'm going to give the step over. That means you people I already explained. So step over for aluminum, if you are running the program into the aluminum workpiece, you give maximum step over 50 to 75 range in between. But if you are running in casting piece, okay, or very hardest piece, you should maintain the step over 10 to 30 in between. Okay, now I maintain 60, minimum 10%, maximum 50% for helical motion. This is a helical motion. Why? Means the tool is directly plunging, the end mill cutter does not have any cutting edge at the bottom of the tool. So that's why we providing helical entry, helical motion. This is also could not written by manual programming. It's very difficult, and the manual programmer trainers forgot to teach this cutting method. Helical entry. This helical entry is only available in CAM softwares. Okay, so helical motion, but the main purpose what is a helical entry is, if example you just see here, very big topic, that thread milling and circle milling is also, both are similar but detailed topic. That's why previously I told you fresher could understand this concept very difficult. Okay, ramping. Now here what kind of ramping? Helical entry is there. So this is the helical entry. Circular ramping. This is a helical entry. So why we are using this one? Spiral motion of the cutting tool that engage all three axes, X, Y, Z axis. This method is typically as radial engagement of the cutting tool. Cutting forces also distributed across the different three axes. So this is the recommended method for longest tool life. Understand? That is a helical entry. So here plunge angle 3 degree, but the notes what they say, soft material means you just maintain 3 to 10 degree for plunge angle, and hard material means 1 to 3 degree for plunge angle. Okay, so minimum 10, maximum 10. The XY clearance I am going to give 0.5, and Z clearance I am going to give 1 mm. Sorry, XY also 1 mm, and plunge I keep it 3, no problem. Now this page is totally completed. This is a default man. Minimum radius 10, maximum radius 50 is default, any kind of operation. Okay, and XY clearance also default, Z clearance also default. Plunge angle, you see the notes, soft means 3 to 10, hard means 1 to 3. Okay, now the finishing, yes, you give finish, then only have the good wall finish for reaming, similar to reaming. Why we people are using reaming? For smooth finish, before entering the tab, before creating a thread. So same concept here, just give finish, but don't give semi finish, you directly go to finish. I just maintain finish pass 0.5. Okay, all depth, don't keep final depth, all depth, because my tool cutting edge is small, I have only 15. Okay, so that's why I keeping all depth, finish pass 0.5. I just maintain the feed rate. How much of feed rate? 350 and 2000. Okay, I just increase the feed rate 500 and reduce the spindle speed 1600. Don't give semi finish. If you need means you just enable and give semi finish, or otherwise you directly go to finish. Transition, yes, this is also very important because lead in, lead out is there. Start at center, end at center, 90 degree, but this one is not required, this one is optional. High speed entry like this. This is high speed entry but not required, optional, but this is very important. Start at center, end at center at 90 degree. Overlap, this is a overlap. Previously we seen in contour, right? Lead in, lead out, overlap, that is the overlap, this one 0.5. Lead in, lead out, overlap. Okay, now go to depth of cut 2 mm. Okay, and linking parameter, Now depth, oh God, 40 mm. But I have only a cutting edge 15 mm. No problem man. You just purchase this kind of tool. Cutting edge diameter bigger, shoulder diameter is small compared to cutting edge diameter. This is a neck type tool. You just purchase, okay, you just purchase neck type tool, no problem. Okay, yes, now the circle milling is developed. This is a tool path of circle milling, and this is lead in, lead out, lead in, lead out. Every time the tool is comes to center, and every time the tool is exit also in center. Okay, starting center, ending center. That option I give here in entry, transition, start at center, end at center. This 90 degree, this angle. This is for tool entry, this is for tool exit. That angle is 90 degree, 45 degree, 45 degree. Okay, 90 degree. Okay, so now here starting angle. What is mean by starting angle? If I am changing here 0 degree, let's see what will happen. Yes, the tool is entering 0 degree, 90, 180, 270. If example I am going to give 180, it will entering here. Let's see what will happen. 183. Super. Yes, this is a starting angle. Okay, this is also your wish. Okay, you will decide in which degree the tool will enter into the workpiece for removing the material. Okay, so now I am keeping 0 degree because that is my satisfaction. 0 degree. So this is 90 degree. This 90 degree here. Okay, here. If example I just change the angle 30 degree means, let's see 15 degree. See, 15 degree. Totally reduce the size of the lead in, lead out. So this is the angle. Okay, I just give 90 degree. Yes, this is enough because radiusly is entering. This is safe for us. Okay, safe for us. And overlap 0.5. Don't give perpendicular man. If you give perpendicular, see, it's look like perpendicular entry which are already we seen in contour. Lead in, lead out perpendicular directly. See here, directly engaging on the wall. So don't give perpendicular entry. Okay, just maintain only start at center and end at center. If you give perpendicular, let's see what will happen. See man, this is a perpendicular. That's why I did not give that one. Okay, this is okay. Let's see the simulation. Helical entry, super. Good. Very good. So the Mastercam is very much because this kind of program is very difficult for you. Because 80, that means 70% people could not understand the IJ program. Only 30% people are understanding the IJ program. But the Mastercam is easily give the program and maintain the 3 mm wall stock for thread milling. Okay. Open circular pocket machining is running now. See? Every time the finishing process is running, finish process running every time. See here, see, finish process running. Every time it's keep 0.5 and again cleaning the, see here, every time it is maintaining 0.5, 0.5 again it's clean. That is a finish pass. Now you people, sir, bottom side, not open sir, not open. It is running the tip of the tool sir. No problem. You increase the value in depth man. No problem. You just increase it. Minus 0.5. That's it. Okay. So this is a circle milling, very easy, very easy. Okay, so here you keep helical entry. Should you give, don't disable. If you disable, the end mill cutter will collide on the top of the workpiece. Okay, minimum radius you keep 10%, maximum radius you keep 50%. How much? 12.5. That 12.5 is this one, this green color. This green color is the 12.5. 12.5 means radius 12.5. So the green color diameter is 25. Okay, if you want to reduce the helical motion little bit, sir, not bigger, I want to reduce the helical motion, means you just reduce the helical motion here, 8 mm, and click OK. Okay, again I am giving here reducing 6 mm. Okay, but not reducing. Why? I keep 25 mm cutter. The 25 mm cutter, once the plunge on the workpiece, means definitely here the maximum radius not controlling. Okay, but if you take more than 50%, means it will control. 25 mm cutter, that is a nature. 25 mm cutter is plunging on the workpiece, means it will create the 25 mm hole only. Okay, so that is a problem. If I give 60%, the hole will, the interpolation will enlarge. Okay, so that's why I previously tell to you 50% is enough. Now the circle milling is completed, then we move to the thread milling. Okay, now I just switch off this one. Again I go to tool path, thread mill. I'm going to select the tool. Before that, how much diameter I'm going to take here? 35. Okay, just go to tool, right click, create tool, thread mill. Next, metric thread, pitch 3 mm pitch, outside diameter 12. Okay, cutting length I am going to get single edge 3. Finish. And the feed rate 50, spindle speed I am going to give 850. Slowly I want to make the thread, or otherwise you give maximum 1000. Okay, plunge rate 600, yeah, no problem, because there is no material inside of the workpiece. Only 0.3 mm stock is there. 600 is okay. Now go to holder. Okay. Cut parameter. Starting angle 0 degree. Allowance overcut 3 mm. Why? Because 38 minus 35. 3 mm. And I am changing here via. If you have the NPT thread, just mention the value here. Tapper thread. Angle. Tapper angle. Okay. And ID thread. Override geometry 35 mm. Okay. But not a 35 mm. My major diameter is 38, not a 35. 38. Right hand thread, bottom to top, and go to lead in, lead out. Start at center, end at center, helical entry, helical entry. Lead in, lead out mm is 5 mm. 5 mm distance. Okay. Multi-pass, yeah, I should give 3 mm is stock on the wall. So here I am going to give finish pass 1 pass, 0.5. Remaining 2.5 I split up it here. So how can I split up? Now I just go to here. So 2.5 divide by 2. 1.25, 2 passes. Okay. I just control the feed rate. So for finish purpose, finish pass. Okay. Which are running nearby the wall. So here 60 and 1000. Now I'm going to give here 100 and here 650. Or otherwise, you reduce the feed rate and increase the spindle speed. That's it. Now the treadmill tool is came. Yes, bottom to top I am going to forming the thread, bottom to top. First multipass is going. This is too difficult in manual program, so that's why he did not teach you, because without understanding he did not teach you. Okay, but I know this thread milling I done in company also. Okay, now the finished multipass is running. See here. Okay, this is the wall thread. We are creating the thread in wall. So not a G84, not M29, not any rigid tapping cycle, G94, G95, anything, does not include anything. See, making the thread on the wall, only wall. But before that, we make the program on circle milling. Just remove the material. Afterwards, you form the thread. Okay, on the wall. Now I done in open thread. Open thread also available in thread mill. See, this is a open thread. Open wall thread. 360-degree rotation. 180 degree tangential exit loop. Yes, I am also give 180 degree here. Where? Here I just give 90 degree la. 90 degree, 90, 180 both are same. That is a exit. Okay. Single edge. This is a single edge tool draw. See, forming top to bottom. This process is top to bottom, but I done it bottom to top. Same process I done here. Same process. Okay, that's it. But you are a fresher. I think Shivashankar is know about this program, but you just fresher. You just go to company and first watch. Don't make the program. First watch